The Microflux control system enables real-time data analysis and control to enhance drilling practices. Using proprietary algorithms, the system detects minute fluid influxes with a degree of precision that is unattainable using conventional drilling methods. Each portion of the Microflux control panel conveys critical information in plots that are easily interpreted. Flow in and out. The blue line indicates flow into the well, while the red line demonstrates return flow out of the well. Density. The blue line shows density into the well, while the red line shows return density. Here, the black line represents surface back pressure, and the red line represents the high limit to the back pressure. As we move right, the blue line represents standpipe pressure, and the green line represents bottom hole pressure. Choke position. The red line demonstrates the desired choke position, and a green line demonstrates the actual choke position. It is critical to identify wellbore ballooning and breathing as soon as possible to preserve the safety of rig personnel and a wellbore's integrity. When drilling conventionally, ballooning is difficult to recognize, and when misdiagnosed, the mud is often weighted up, only worsening the situation. The Weatherford Microflux control system offers enhanced wellbore monitoring capabilities to detect a ballooning or breathing incident at its initial stage. Using the Coriolis meter's real-time flow-out data, the Microflux software plots flow-out patterns while pumps are cycled, the pivotal factor in determining whether a wellbore is ballooning or breathing. The following video demonstrates Microflux's ability to clearly and instantaneously identify wellbore ballooning and breathing during a standard connection in an offshore well at 14,918 feet on bottom. Note that flow in and flow out are equal before the driller brings down the pumps. Under normal conditions, flow out and flow in are closely aligned as the pump rate decreases. However, in this particular scenario, when the pumps are completely off, flow in is 0 and the flow out measures about 200 gallons per minute. Approximately 45 seconds after the pumps are turned off, flow out comes to a stop, allowing the rig crew to make the drill pipe connection. Taking a closer look, notice the system detected a breathing instance with a net gain of 198 gallons from the time the driller began turning off the pumps until flow out reached 0. Upon completion of the connection, the standpipe is filled and the pump rate is restored to the normal drilling rate. As the pump rate increases, the flow-out lags behind, indicating a loss to the formation. What we are seeing is common ballooning behavior. The well is taking back the fluid gained during the earlier breathing instance. The Microflux control system actively monitors the gradual decrease of flow out towards 0, signifying that there is not an influx. Notice that the amounts of fluid that were lost and gained during wellbore ballooning and breathing were almost identical. The system detected a loss of 196 gallons during pump ramp-up, which correlates very closely with the 198-gallon gain that was seen during the pump ramp-down. Unlike in conventional drilling, increasing the mud weight is not the appropriate response here. Following the identification of a ballooning or breathing event, adhere to standard mitigation protocols.